So, when you hear the word engineering, what pops into your head? Probably bridges, right? Or maybe circuits, or some kind of complex machine. But what if I told you that engineering is actually a blueprint for thinking? That it's a method for solving almost any problem, whether it's made of steel or systems? To really get that, we have to start with a question that sounds, well, a little strange.
I know. It sounds like the beginning of a really bad joke, doesn't it? What could a middle school project made out of pasta possibly have in common with an advanced university degree? Well, the answer is surprisingly simple, and it's going to completely reframe how we think about engineering. And yeah, we'll get to the punchline by the end of this.
You know, the foundation for this really big idea actually starts small, like really small. We all begin learning to think like engineers when we're kids, a lot of the time, without even realizing it. These aren't just fun little activities in the classroom. They're our very first taste of a powerful, universal process. And that's the thing. It doesn't matter if you're building a skyscraper or planning a software update. I mean, the scale and the materials might change, obviously, but the core methodology, that mental blueprint for getting from a problem to a solution, it stays exactly the same. And this is it. This is that process. It all kicks off with a question. What's the actual problem we're trying to solve here? Then you do your homework, you research what's already out there, you imagine all the crazy potential solutions, then you plan a specific approach, you create a prototype, and finally, you test it. This six-step loop right here, it's the engine that drives all innovation. And you can see this process in action super early on. Like back in 4th or 5th grade, you might create an electromagnet. You ask, you plan, you create, and you test. By middle school, things get a little more complex with something like a spaghetti bridge. Now you're analyzing forces to see how much weight it can hold before it, completely shatters. It's the exact same problem-solving process, just leveled up. So how does this scale up for real? Well, those classroom projects are the bedrock for a professional career. The tools get way more sophisticated for sure, but that fundamental mindset we learn from a bunch of pasta, that's what guides every single professional engineer. Now, at the master's level, that engineering mindset splits into these really fascinating specializations. On one side, you've got engineering management, which is all about engineering the process, managing the teams, the budgets, the workflows. And on the other, you've got something like MEP, mechanical, electrical, and plumbing, which is all about the technical design of physical systems, like the heating and cooling in a skyscraper. Two totally different careers, but both are powered by that same core design process. And if we zoom in on the engineering manager, we see something pretty profound. Their job isn't just about building things. It's about building the systems that build the things. They're applying that same engineering process to people, budgets, and deadlines. They are essentially engineering the team itself. And this is where our whole definition of engineering starts to get really, really interesting. So, if you can engineer a team, what else can you engineer? This brings us to the most important point of this whole explainer, the idea of applying that same structured, problem-solving mindset to the system of education itself. This quote just nails it. It reframes a curriculum designer not as just a teacher, but as an engineer, someone who systematically investigates and designs the information systems that deliver knowledge. It's a total paradigm shift. And there's a name for this, curriculum engineering. It's all about treating an educational program like a machine. It has inputs, it has processes, and it has clearly defined outputs. And this is the crucial part, it has feedback loops to measure what's working and identify points of failure that need to be redesigned. This whole concept of engineering abstract systems isn't just for education either. It's a seriously powerful tool that's being used to solve incredibly complex problems in business, in finance, and in compliance. Just look at this slide for a second. You can see exactly how a curriculum becomes a closed-loop system. You define your goal, you deliver the material, you assess the results, you analyze the data, and then boom, you use that feedback to improve the system for the next cycle. It's the engineering design process all over again. Ask, plan, create, test, and repeat. Okay, and check out this incredible example. This describes an audit system that's literally engineered to be a nervous system for a company. It uses algorithms and automation to constantly monitor compliance in real time, finding and fixing problems before they even happen. And get this, it reduces human error by 40%. This is 100% engineering, but the materials aren't concrete and steel. They're data, logic, and processes. All right, let's bring this all back together. We started with a simple spaghetti bridge, and we ended up with an automated corporate nervous system. The journey between those 2 points reveals a new, much more powerful way to think about what engineering really is.
So here's the big takeaway. Engineering isn't just a profession for people who are good at math and science. It's a mindset. It's a reliable, structured process for designing and improving any system, whether it's a physical thing, a business process, or even the way we learn.
And that right there is the answer to our question from the very beginning. What do a spaghetti bridge and a master's degree have in common? They are both products of the exact same blueprint for thinking. They both rely on that fundamental cycle of asking a question, planning a solution, creating a version of it, and testing the result.
And that leaves us with one last question, really. This mindset isn't just for professionals. It's for anyone who wants to solve a problem effectively. So take a look around. From your personal budget to your study habits or your team's workflow, what systems in your own life could use a little bit of engineering?